Alright, so here we're going to look at solving exponential equations where the exponentials have different bases. So as you notice here, this one has a base of 5 and this one has a base of 7. So what you should notice first of all is that I actually can't go ahead and straight take the logarithm on both sides here. The reason for that is because I've got 0 on this side and I can't take the logarithm of 0. Okay, because it's actually undefined. The logarithm of 0, if you were to punch it in your calculator, gives you an error. Okay, so first of all, what we need to do is to not have a 0 over here. So the easiest way to deal with that is to take this piece and get rid of it from this side and move it to the other side. Well, this 7 to the x plus 1 is actually negative, so to get rid of that I could add 7 to the x plus 1 to this side of the equation. That would cancel it off. And if I add it to that side of the equation, then I add it to this side as well. So then that gives me 5 to the x minus 2 equals 7 to the x plus 1. Okay? Now, I can go ahead and take the logarithm of both sides. It doesn't matter what base of logarithm I use. For simplicity, I'll use base 10 here. Okay? So now, I can use my power law, so I can take this exponent here and bring it down in front of the logarithm, and then I can take this exponent and bring it down in front of the logarithm. So this x minus 2 comes down in front of the log 5, and then this x plus 1 comes down in front of the log 7. Now, you might notice now that this is really a distributive property. This is log 5 times x, and then log 5 times negative 2. So x times log 5 is actually x log 5. Okay? 2 times log 5, I can just leave as 2 times log 5 for now, so 2 log 5. I distribute on the other side as well. So I've got x times log 7, which is x log 7, then 1 times log 7 is log of 7. Okay? So now I need to try to solve for x here. So what I'm going to do is take these x terms and put them on the same side of the equal sign. So I can put them both on the left side or the right side, doesn't matter. For now I'll put them on the left side. So that means I'll have to take this piece and push it to the other side. So right now I notice that it's a positive x log 7. So to get rid of that, I would subtract x log 7. If I subtract x log 7 on this side, I need to subtract it on this side. So then this gives me x log 5 minus x log 7. I'll leave this piece here, so minus 2 log 5 for now. Equals on this side, all that's left is the log 7. Now I need to isolate my variable. I need to get my x terms all alone. So that means these guys are on the same side of the equal sign, but this thing doesn't have an x, so I need to get rid of it from this side. It's negative, so to get rid of it, I could just add it. So I add 2 log 5, cancels off there. Of course, what I do to one side of the equation, I need to do to the other side, so I add 2 log 5 there. Okay, so that gives me x log 5 minus x log 7 equals log 7 plus 2 log 5. Okay, so what I notice here is on my left hand side I actually have a common factor of x. Okay, so I'm going to factor out that x, and what's left when I take the x away from this log 5 term? Well, you can see that just the log 5 is left, so log 5 has to go here. When I take the x away from this term here, I can see that log 7 is left, so that leaves me with a minus log 7. Of course, minus because it's negative there. The right hand side I'll leave the same for now. So now what I have is a variable times some kind of number. So to solve for the variable, I just need to get rid of this number here. So since it's multiplied by x, to get rid of that number, all I'd have to do is divide by it. No matter how ugly the number is, you just divide by it. That cancels it off. Of course, what you do to one side, you do to the other side then. So then I've got log 5 minus log 7 here. So So this essentially leaves me with my answer now. So I've got x equals log 7 plus 2 log 5 over log 5 minus log 7. Okay? Now, what you'll need to do is estimate it by punching it in your calculator. You have to be really careful punching this in. It's easy to make a mistake. What I usually recommend is evaluate your numerator and denominator separately. So in this case, I'll do log 7. So log 7, close off my bracket, plus 2 times log 5, close off my bracket. So that's my numerator. I press enter, and it gives me approximately 2.2430. So 2.2430. Now I evaluate my denominator, which is just log 5 minus log 7. So log 5, close my bracket, minus log 7, close my bracket, which gives me negative 0.1461. And now I just divide these numbers. So that would be 2.2430 approximately divided by negative 0.1461, which gives me negative 15.352 approximately. Okay?